Hello everyone. Today we'll do a numerical on design of a pile cap for four pile group. So let me just write the name. Design of pile cap for four pile group. So in this problem, the number of piles is given. Number of piles is given as 4. Pile diameter is given. This is 0.5 meter. Then safe load on pile, okay, Q allowable load on pile is given as 168.76 kilonewton. Allowable load on single pile, okay, on a single pile. So column is given, column size 0.4 meter by 0.4 meter. Material is given M20 concrete and Fe500 steel. Okay, so now let us start off with the numerical. So first, when the pile is given to us, pile diameter, then we can provide the pile spacing accordingly. We take it as 3 times of the dia of pile. Is equal to 3 into 0.5 meter is equal to 1.5 meter spacing. Okay, now how will we size the pile cap? Design of pile cap means finding out the size. So now let us assume that this one is the top view of the pile cap. So the pile was 500 by 500. Okay, if I consider it like this, 500 by 500, 4 pile group. And their spacing is 1.5 meter. Okay, now if I consider like the diameter is 0.5, this diameter we know it is 0.5. So we can do one thing, we can consider the distance till the edge of the pile as half of the pile diameter. So we can take it as 0.5 by 2. Okay, everywhere distance from the edge of the pile we take as half of the pile diameter, 0.5 by 2. So what will be the distance from the center? So this one is also 0.5 by 2 and this one is also 0.5 by 2. So ultimately this will be 0.5 everywhere. So everywhere it will be 0.5 till the center. Okay, so if this is 0.5, then ultimately the size of the pile cap will become 1.5 plus 0.5 this way on the left plus 0.5 on the right. So we can say that the pile size is 2.5 meter. Okay, this way, so the pile dimension we can take it as 2.5 meter by 2.5 meter. Now, if I have to find out the bending moment, so let me go make another diagram for finding out the bending moment. The column, we always take the bending moment at what? At the column face. So if this is the center, so the column was 400 by 400, 0.4 by 0.4. Okay, this one is 0.4 column. Now the piles were like this: 1, 2, 3, 4. So now the first we have to find out the distance of the pile to the column face, this much. Okay, what is the distance of this pile from the column face? So we know that this much is 1.5 by 2.5 by 2. So let me just calculate 2.5 by 2, or you can say 1.25. Okay, this one is 0.5 and this one is 0.2. So what is this x? X will be equal to 2.5 by 2 minus 0.5 minus 0.2, which is equal to 0.55 meter. This one will be 0.55 meter. So moment at the column face, if this is the section for the column face, we can consider the moment either from the left or from the right. So let us consider the moment of the forces from the left. So on the left, the two forces will be the two loads on the two pile. Okay, so I'll show it here itself. So we got that the load was how much? The load given in the question was on a single pile, it was 168.76 kilonewton. Okay, so the load for design, we take it as factored. So the factored load will be 1.5 into 168.76. So you calculate how much it becomes. 1.5 into 168.76, 253.14. So this here it is 253.14. Here it is 253.14. Okay. So if I now look into the top view, so sorry, not the top view, the front view. So it will simply look like this. Okay. If this is the pile cap, if this is the column, and these are the piles. So this pile is having that load, how much it was? 253.14. 253.14. This is going through the CG of the pile, and this distance is 0.55. But we from the front view we can only see one pile here, but there are actually two piles. The another pile we cannot see because it is on the back side. Okay, so there are two piles. So ultimately, the moment that they will give in the column face will be 253.14 into 0.55. That is the load into the distance of the load to that particular section. This is the section where we need the moment. We need the moment at the column face. Now, and there are two piles actually. On that side also there is one pile which we cannot see because of the front view. So that will be the total moment. So you calculate what will be the total moment here into 0.55 into 2. It becomes equal to 278.45 kilo Newton meter. 278.45 kilonewton meter. Now, we have got, when we have to do the design of a pile cap, we have to actually design the size and the reinforcement, right? So size, we have already calculated the width. Width was 2.5 meter. Now we have to find out the depth of the pile cap. So moment we have got, so mu, if I consider for Fe 500 and M20 concrete, it is 0.133 FCK BD square. This implies D is equal to root over mu by 0.133 FCKB. So it will ultimately become how much? The moment was 253.14. 253.14 into 10 to the power 6 by 0.133 into FCK was 20 into B was 2500. So you calculate how much it comes. So root over 253.14 into 10 to the power 6 by 0.133 into 20 into 2500. So it is coming around 195. But we don't provide so less depth of a pile cap. Okay, we don't generally provide so less depth for a pile cap. So what we do is we don't go with that. We take the depth of the pile cap, suppose D, as twice of the pile dia at least. Okay, so it is like a you can say a convention. Okay, so twice a pile dia means 2 into 0.5 meter. Pile diameter was 0.5 meter, so it is 1 meter. Or we can say 1000 mm. It's like a convention. Okay, 1000 meter mm. So we take this. Okay, 195 for a pile cap, 195 mm is very less. We don't provide so less depth of pile cap. Okay. Now, if this one, if I take a cover of 100 mm, so effective depth of a pile cap will be 900 mm. I take a cover of 100 mm. Okay. So now we have to find out the area of steel, isn't it? So AST is equal to 0.5 FCK by Fy 1 minus root over 1 minus 4.6 mu by FCK BD square into BD. So ultimately it will become 0.5 into 20 by 500, 1 minus 4.6 into 253.14 into 10 to the power 6 by 20. B is width of the cap is 2500, and these we can take as 900 square into 2500 into 900. So if I do this, let's find out what will be the value. 0.5 into 20 by 500 into 1 minus root over 1 minus 4.6 into 53.14 into 10 to the power 6 by 20 into 2500 into 100 square into 2500 into 900. We get around 650. 1 mm square. Now we have to check whether this is satisfying the minimum steel requirement or not. Okay, we have got that area of steel is 651, but minimum steel that we have to provide anyhow, we have to check whether it is satisfying that or not. Is 12%, sorry, 0.12% of gross section of cross section, which is equal to 0.12 by 100 into width into depth 2500 into 1000. So it's coming as 3000 mm square. But this much we have to provide anyway. Okay, so 3000 mm square we have to provide anyway. So if I consider now 16 mm dia bars, so area of one bar, we can simply take the number of bars equal to equal to 3000 by area of one bar, which is equal to pi into 16 square by 4, which is equal to, let's find out, 3000 by pi into 16 square by 4. 14 number of bars. So it's around, we take it as 15 bars. Okay, so we have already got the number of bars here. Okay, so how will we know the spacing of the bars now? So let's just find out. This is the pile cap. So in the pile cap, what we do is, if there are 15 number of bars, okay, if there are 15 number of bars, then what will be the number of spacing? What will be the number of spacing here? If there are, suppose example, if there are 4 bars, the number of spacing is 1, 2, and 3, 3. So if there are 15 bars, then there will be we can say 14 spacings. Isn't it? 14 spacings. So we have to check like how much spacing we can provide equally in 14 parts. Okay, so if this is 2500, and since pile cap is a very big structure, so if I take suppose a cover of 200 both ways, 200, 200. So what is the area remaining where we will provide the bars? This much area. So if there are suppose 15 bars like this, and I will not draw 15, just I am representing. If there are 15 bars in this, what is this spacing? This one is will be becoming 2100. Okay. So if there are 15 spacing, 15 bars provided like this, if there are 15 bars provided in this manner, then there will be 14 spacings. So each spacing will be equal to how much? 2100 by 14. Okay. So it becomes 150 mm. Okay, so we give 150 mm spacing. So we have got like 16 mm bars, 150 mm, center to center. This is the, like, we have already got this pile size. Pile size is done, pile depth is done, and the reinforcement is done. So this is the end of the problem. Okay, thank you.